Hey everyone, welcome back to my YouTube channel. It's Max, and today we're doing the second video in our video series about how to make your own crypto app. So if you're just watching this video and you haven't seen the first one yet, I've linked it down in the description below, but that's going to go over like what this whole video series is about and about the theory of operation behind all the stuff we're going to code up in this video. But for those who are caught up, this video we're going to actually start coding up our Enigma machine for doing our encryption and decryption in our app. Here on the left is a diagram showing the architecture of the class we're going to implement for the Enigma machine. On the left, we have our data. And for the data, there's not too much. There's basically just the rotors themselves and how they map letters, and then the plugboard or reflector element here. And then the other thing we need is to some values to describe the initial positions that the rotor started when the Enigma machine, when we create the first instance of that. For methods, there's still not too much. We need a way to map letters using the rotor. So that is from the last video, when we input a letter into the rotor, what's the output letter going to be? And then we also need the reverse process as the data flows back through the Enigma machine for the second pass. We also need a way to convert a string of text to an array of ints, because we're going to be using the Ascii convention to describe all of the characters in the string as ints. And so we need a way to convert that string to the Ascii to an array of ints. And also, once we do all the encryption and decryption, we also want to convert that array back to a string to present to the user. We need a way to shift the rotors. So this is for the actual encryption part, where once every letter passes through, one of the rotors will shift one position. And then like the fast rotor will shift once every one letter, and then the middle rotor will shift once the first one goes around, and so on. We also need the rotor shifting to set the initial positions of the rotors on startup. The last method we need to implement is really the thing that ties everything together, and that's the full encryption implementation. One thing that I want to do different from the demo in the previous video is I don't just want to use the capital letters between A and Z. I want to use a lot more characters. That way we can have a much more sort of hard to break crypto system. So right here I have the Ascii table in front of us. And I'm just kind of going through here to see, what characters do we want to understand, like what kind of range of ASCII do we want to make the rotors consist of. So if we're looking through here, here's the capital letters, here's the lowercase letters. Up here it goes to space for ASCII 32. And then here's a bunch of I'm not really sure what these are, and I'm not really sure how they would show up in plain text. So maybe we should start with 32 for space. Looks like we have a lot of punctuation here, numbers. And then maybe 32 up until, yeah, let's go up until the tilde. So that way in our sort of alphabet now for how we're gonna map letters, or I guess just not letters, like different ASCII symbols, we'll have everything from an empty space all the way up to a tilde. Since we're using a lot more than just the regular 26 letters in the alphabet, we're probably not going to want to make these rotors by hand. So the first thing we'll do is probably make a small program to actually create the rotors ourselves. So since we're going to be using the characters from ASCII 32 to ASCII 126, that's going to be a 94 character array. And we'll use the convention that the index of the array will describe the input character, and then the element of the array will describe the output character. And just to make the implementation simpler, we'll subtract off 32 from all of these values, and we'll add it back on later, but just so we'll have characters described with the numbers between 0 and 93. That'll just make the implementation a lot easier. And if that sounds a little confusing right now, I think as we implement it, it'll become much more clear. Okay, so here I have just a new project. This isn't actually like an app, like a desktop application or anything like that. It's just a console app in Visual Studio. And that's because this isn't actually we're not actually going to start building the application yet. We're just going to write some code to actually generate the rotors. We've got 3 arrays. So the first thing we're going to do is just fill them up with the numbers between 0 and 93. And then to make them sort of randomized rotors, we'll start continuously swapping elements as a way of shuffling the characters up. Okay, so now we're just going through and for 1,000 times going through all the elements that are ordered in the first rotor and just continuously randomly swapping them around to jumble it up. And then we're just going to repeat that process for the second and third rotor as well. Cool, so now we've got all the rotors swapped. Now we need to make the reflector. The reflector is pretty similar to the rotor, except that all the letters have to be swapped in pairs. And all that means is that when two letters get swapped, we don't want to swap them again. So we just need to remember which letters we've swapped. Now we've got the reflector set up. So let's just run this and see what happens. We should have 4 arrays that just basically have a bunch of jumbled up values in them. Let's run it, make sure everything looks good. Oh wait, let's actually just put a breakpoint so we can look at our data. Let's break, run that. Okay, what the heck? Here we go. Okay, so let's look at R1. We should have a jumbled up array, and sure enough, we do. Cool. So there's our first rotor. There's our second rotor. Our third rotor. Again, they're all randomly jumbled up and shuffled. That's good. And now the reflector should have pairs of swapped elements. Okay, so 0, 0, that's good. Element 1 has 66. That means position 66 should have a 1. Let's just make sure that that's the case. It's not. Something went wrong here. So, oh, here's what's obviously wrong. We never added our elements that we swapped to our already swapped list. So let's go back and fix that. So if we swap already swap dot add, we need to add rand a, and already swapped elements dot add, need to add rand b. Okay, so that should fix that problem. Let's check the reflector again. Come on. Okay, again, 0, 0. Position 1 has 4, so position 4 should have 1. Cool. Position 3 has 50, which means position 50 should have 3. Okay, this is looking good. So it looks like the script we have has properly set up the rotors. Now we just need to export them to like a CSV or something, and we're just going to copy and paste them into the main application code as like hard-coded arrays. So now we need to just do some exporting. Yeah, so here we're just writing the array. We're just writing the array R1 to a file called rotor1.csv, and we're just using this write.endString.join method with the comma separator, and we'll just do that for all the rotors in the reflector. Okay, so now we've got all the exporting going on. Let's test out and see if we got our rotors generated. Okay, so here's the application I just made to make the rotors, and in the binary there should be some CSVs. Awesome. Let's see if they look good. Perfect. Okay. Got a reflector. And we've got rotor 1, and okay, perfect. We have all of our rotors. I just made another console application, and we're just going to use this to develop the Enigma Machine class and then use it to test. It's going to be a lot easier to test the class in a console app than in a fully functioning like WPF or WinForm app. So yeah, for the first step, let's start importing the rotors. Okay, now we've got our our rotors hard coded and imported into our class. Let's see what's next. So next, let's define a shift operation. So that'll be just sliding all the elements in the rotor one position over. Okay, we've got shift made. So we're just going to go through all the elements and um, sort of like shift them along, and then just remember that store the last element and then wrap that back around to the 0th position. Okay, what do we have next? Okay, so next we can do the converting a string to an Ascii array. Now we've got our string to Ascii array conversion. And here what we're going to do is take in the string. So this is the text we want to encrypt or decrypt. First convert it to a char array. So this is just an array of each individual symbol. And then from there, we can take each individual symbol and cast it to an int, and that'll map it to its ASCII value, and then subtract 32 from it because 32 is the lowest ASCII index symbol that we were going to use. All right, sorry about that, everyone. Some stuff came up and had to stop filming, but we're back at it. So I think the place we left off was making the method that's the opposite of the string to ASCII, converting the ASCII array of ints back to text. So let's start that. Cool. So now I think we've got our ASCII array to string, and it's basically just going to be the reverse of the method we last made. So taking in now an array of ints, each one corresponding to an ASCII symbol, and then for each element in this array, we're going to add 32 to it to undo this subtraction of 32 in the previous method, cast it to a char, and then just consolidate all the elements in the char array back to a new string, and then return that value. Okay, let's see what we have next. So we've done the rotor, or we've done the string to ASCII, rotor shifting, ASCII to string array. What else do we have? Looks like, okay, so it looks like the next two things we should probably make are the rotor mapping and the inverse mapping. The way that this method's going to work is it's going to take in one of the rotors, so one of these arrays, as well as an int representing one of the characters we want to convert or pass through the rotor. And the convention we're going to use is that the indexes of the array are going to correspond to the inputs to the rotor, and the elements in those positions are going to be the outputs to the rotors. Yeah, I guess that's the whole mapping. Next, we need to do the inverse, though. So have a similar format, public. Should be the reverse of the above method. Now, this is saying, for example, we need to know what index in the rotor, for example, the value 20 appears. So if the value 20 appears in the 7th position, we need to return the 7th position. So like rotor in the 7th position equals 20. Okay, let's look at the last methods we have. We've done the rotor map, the inverse map, the ASCII array conversions. I think the shifting was the first thing we did. Yep, we did already the shifting. Cool, so the last thing we need to do is just actually set up the encrypt method. Okay. Oh, and we'll still have to make a constructor for the class too, for the testing, but for now we can still start writing the encrypt method. I think we've got the main encrypt method done, and let's just go over this briefly. So all we're going to do is the encrypt method should take in a string, a message, and return a string, the ciphertext. So first thing we got to do is take our message, convert it to an Ascii int array, and then we'll also make another int array to store the ciphertext values as well. Have some variables here to keep track of how much the rotors are shifting, because once one rotor goes all the way around, we want to shift the next rotor one element over. Then once that rotor goes all the way around, we want to shift the last rotor one position as well. And once we have all that set up, we're just going to go through each letter in the ASCII encoded message, process each one at a time through the Enigma machine, and encrypt them one by one. So for each letter in the array, first pass it through the first rotor, then pass it through the second rotor, then pass it through the third rotor, pass it through the reflector, and then pass it through the rotors in reverse, going from rotor 3 to rotor 2 to rotor 1. I think I have a little mistake there. That should be a rotor 2, and that should be rotor 1. Some copy and paste mistakes. And then once we've gone through the first rotor in reverse, that will be the encrypted ciphertext, and we'll store that in our array. And then once we've gone through the whole Enigma machine, we want to start shifting the rotors. So every time we pass a letter through, we're shifting the first rotor one position, and then we're just keeping track of how much we've shifted each rotor, and then deciding if we need to shift the next one. So if the first rotor has shifted more times than has basically gone all the way around, is what this is saying, reset the shift count to 0, and then shift the next rotor over one position and increment that rotor shift count by 1. Then if the second rotor has gone all the way around, then we should reset its shift count and then shift the third rotor one position over. And I have the third rotor incrementing its own shift counter as well. We're not actually using this anywhere, because no matter how many times the third rotor goes around, which is the slowest, it doesn't do anything. So you don't really need this, but just kind of had it there anyway. Then once that's all done, take your array containing all of your ASCII ciphertext, convert it back to a string, and then return that string. Last thing we need to do is make a constructor so we can actually create an instance of an Enigma machine so we can test it. So let's do that. Here's our constructor. It's not really doing too much. We just have 3 inputs, and basically these are the settings for the Enigma machine. And these are how many shifts do you apply to each rotor before you start using it. That's what's going to differentiate two people with the same Enigma machine, how they're going to configure the machine to start encrypting messages. And then so this these are just how many times to shift. So this is 5, that means shift the first rotor 5 positions, shift the second rotor 10 positions, or etc., etc. Now that we have that made, that should be the last part of the class, and now we can start testing. Here we are in the sort of main testing class. So let's make an Enigma machine and try to encrypt a message. So let's first make a message. So assign maybe like hello world or something. And I'll put some exclamation points too, to just show that we can encrypt the punctuation and the space as well. Machine, I don't know, X. These are just some random settings that we'll use. And okay, let's try to see if we can do some encryption. So string ciphertext. Whoops. Okay, let's see, where is our output? Where is the output? Oh no, something's wrong. The shift is broken. Yeah. Shouldn't have that. Yeah, we don't want to do an n-1 when n's allowed to be 0. That'll screw stuff up. Let's try this again. Did anything come out? You know what we'll do? Using system.d diagnostics. Debug.writeLine. Something I'm always not used to with C#, that the console always just goes away, so you have to do this system diagnostics namespace. Okay, so hello world got encrypted to this. You know, actually, let's just do it this way. This will be a better way to test. Then we're just going to make a new Enigma machine and convert it back. So we'll have another one. Let's be Enigma Machine Y. Let's try this. So we have a message, just hello world. We're going to make one Enigma machine with a certain set of settings. We're going to use that machine to encrypt our message into ciphertext. Then we're just going to display that on the screen to show the message and the decryption. Then we're going to have, or the encryption, sorry. And then we're going to have another Enigma machine Y set to the exact same settings as X. And this corresponds to the machine that the other person would have that you're talking to. And we're going to take that machine and give it the ciphertext generated by Enigma Machine X and create some decrypted text. And if we've done everything right, these two will match. Whoops. This needs to be ciphertext. Okay, so looks like we did not get hello world back, so something here is wrong that we have to figure out. Oh, this needs to be x plus 1, should be x event. Let's try this. Oops. Oh shoot. This does need to go to 0. Okay, let's try this again. Cool. Okay, we fixed our fixed the problem with the shift. Just this. Actually, that was right the whole time. This indexing was wrong. Cool. So now we've taken some message in plain text, hello world. We've encrypted it to some ciphertext here, and we've shown that if we create a new Enigma machine with the same settings as the original one, so an Enigma machine Y with the same settings as X, then when we pass in the ciphertext, it returns hello world. Cool. So I think we're gonna end the video here. I know that was probably longer than I expected it to be, but yeah. So now we've got the main class to do our encryption and decryption, and in the next video, we'll start actually designing the GUI of the application, and then integrating this encryption class into the GUI and do some more testing there. Thank you all for watching. If you like this kind of content, feel free to like, comment, and subscribe. And yeah, I'll see you guys next time. Bye.